I'll get my slides ready to go. 55 today, 4 plus 1, 8. That is like 10. That's 10 slides. Textbook. Oh, got one. All right.
Good afternoon, sir.
Good afternoon. How are you doing?
Good, sir. How are you doing? Thanks.
I'm doing all right. Just looking over the book, trying to get ready. We're going to start on page 878 is where we're going to be.
Okay.
So I'll go ahead. I'll get started on this, and then if anyone joins afterwards, they can catch up and see what they missed on the video when I send it out, once it's recorded. So just done that. Going over again, gas heat, unit 31, staying in that, just focusing on gas heat. Two-stage gas furnaces, there is a short paragraph about them. We'll talk about them a little bit, but today that's part of it. We'll talk about modulating gas furnaces. That's the more complicated side of things. We'll probably, I'm going to show some videos and send some out for you guys that will actually show a modulating gas furnace and how it operates, how it can change speed and heat level based on, the requirements. That's, how cold it is outside. So they're really, really interesting devices. They work really well. Excuse me, too much seltzer. So it's pretty much what everything's going to nowadays. The 90% gas furnaces are becoming 90% modulating furnaces, where it's, not just 90, now it's 97% efficiency for that AFU rating. So you're only having 3% of your fuel escape out as gas going into the atmosphere, or wasted heat going out into the atmosphere. So that's the nice thing about those. And then variable output programmable thermostats. These are super high tech. I've worked with some of these before. There's a couple of different brands. Most of the time, what I've seen is the manufacturer of the unit will make their own control board for the indoor unit, make their own control board for the outdoor unit. That control board with these new high-end ones will be like a computer, and it's going to have a microprocessor in it, and it's going to have a circuit board and a motherboard and memory and all that kind of stuff. And they'll have it on the indoor unit and the outdoor unit, and then they'll also have it on a thermostat. And I've seen thermostats that are cool and sleek, little tiny squares that are all touch screen with memory logs and all that kind of stuff. And then I've seen other ones where it looks like an iPad is how big it is. It's a massive touch screen that works really, really well. But it just depends on how much are you willing to pay. That's the end of the day. What are people looking to do? So two-stage gas furnaces. This was one of the earlier forms of controlling gas flow and making it so we had a modulation of some sort. It wasn't able to modulate truly. Modulation is we can go from 0 to 100, and we can go 1% at a time, basically, as far as the increase of speed, the increase of heat production. It's just incremental, little 1%, 1% added on at a time. With the two-stage gas furnace, gelante. With the two-stage gas furnace, we had a low speed and we had a high speed, and that was it. Just 2 stages, 2 speeds. So you would have it where the gas valve would be a 2-stage gas valve. You would have it where it would introduce the initial burning gas, and then it would have basically a low setting for the burners and everything like that. And then it would have a high setting where it would be, okay, now we have to get it into more and more heat. Let's open up the gas valve all the way and get the heat producing even more. Now, most systems nowadays usually are straying away from these because they're kind of limited. You got 2 speeds and that's it. So it's either low or high. It's never going to be in that middle ground. So if it's kind of cold day, you might see it where all of a sudden the AC is kicking on, the heat, I should say. The heat's kicking on, and it's going full blast, even though it doesn't need to, but it can't go, it's too cold to go low speed. So it's going to have to make up its mind as to which way it's going to go. That's the interesting thing with this as far as the 2-stage system. The other thing with it would be that you've got it where your inducer draft motor and your blower motor were also at least 2-stage. The blower motor, typically at that point, you would see it where it'd be at least a 2 or 3 speed motor. So having a 2-speed blower motor, having a 2-speed inducer draft motor was the tougher thing, because now you had it where it would be pulling enough air for combustion for basically half the level of gas, and then 100% of the gas, it would have to kick it up into a higher speed. So most of these devices and everything like that we've got for 2-stage gas furnaces, it was just the earliest first step we had for a gas furnace to start to be efficient. Prior to this, it wasn't even considered, well, man, you got a gas furnace, that's just going to burn a hole in your pocket if gas prices ever go up, and at least in Virginia and everything like that. For other states and things like that, it just meant that you had it where, when you're up north, you're going to have expensive operation to do your heating. It's not going to be cheap. So it was a good way to really break make it so that, the heating season wouldn't break the bank in colder climates when they first came out. What's more common nowadays, so like it says here, first stage puts out a manifold pressure of 1.75 inches of water column. We know that natural gas should be at about 3 to 3.5 inches of water column. Sorry, my dog's being really weird. 3 to 3.5 inches of water column. What are you doing? She's fine. Sorry. 3 to 3.5 inches of water column. So this is about half of that pressure. 3.5 divided by 2 is about 1.75. So, it is 1.75. So this makes sense as far as if it's going to go into half speed and half heat, it's going to be half gas pressure. So that was the nice thing about these manifolds and how the gas valve actually was able to not just turn on and be all the gas at one time. It would actually control, okay, only 50% of the gas or 100% of the gas. And you see here it's saying 50 to 70, just depends on manufacturer and how it was first assembled and everything like that. So second stage, like I said, that's when it's going to go full. It's going to go to that 3.5 inches of water column, just like we would normally see on any other gas valve coming out of the output side for the pressure. So that's when we're going to see there's our full pressure. The thing about these to understand when you're troubleshooting, when you're maintaining them, is to check and see, okay, if it's a two-stage gas furnace, does it, is it in the first stage or is it in the second stage? And if you're checking only first stage gas pressure, what you can do that's an easy thing is hit the thermostat up 1 degree, just 1 degree. And if you go up 1 degree, all right, it should kick on that first stage heating. And that should, that would only come on, and that would be the only amount of heat that would be allowed through. Now, should, depends on the manufacturer. To get on, if you're checking for second stage pressure, if you just want to look at that, just crank up the thermostat 2 or 3 degrees at least, and it's going to go full speed, full gas pressure, everything like that through the system. So these are not terribly difficult to troubleshoot. They're pretty simple, but they, like I said, not super common here in Virginia that I've seen at least residentially, but they used to be a very, very popular option. Nowadays, everything is switching to what we're going to talk about next, which is modulating gas furnaces. So your book has got it on page 879. Modulating gas furnaces, it talks about them in great detail. Please make sure to read through that, especially when you're doing your homework questions or anything like that. You're going to be, make sure to read through the chapters. It's got a lot of stuff that we could go into, but it's easier just if you read it. So the nice thing about modulating gas furnace is, like I said, it's going to modulate. It's going to ebb and flow. It's going to allow for it to pick up high speed. It's going to go into a low speed. It's going to get into a middle ground. It can go all sorts of different speeds. The way that it does this is usually through variable speed drive motors, or what are they called? Oh Lord, I'm brain fart. But the excuse me. But the modulating motors allow it so it can go from, like I was saying before, basically imagine percentage, 0%, 100%. All right. We looked at the two stage. It can either be at 50% gas production and heat production, or it can be at 100% gas production and heat production. With the modulating gas furnace, it can go from 0 to 100, and it can go in increments of 1% at a time in theory. Depending on the brand and the manufacturer, it might only have 10 speeds of heat, but still 10 speeds of heat is really, really, really good. More often than not, though, it's going to be with the modulating ones, they'll have it where it's going to be, way more than that. It'll be 25, 40, 50, 100 speed settings for the blower motor, for the gas valve, for the inducer draft motor. Pretty much all of our different components are all going to be able to modulate and ramp up their speed and slow it down according to what's the load. So when these systems are typically put in, it's going to be in a newer construction home. It's going to be in something that's got greater energy efficiency as far as the style of windows, the type of insulation in the attic, the type of insulation in your duct, in your crawl space, and all that kind of stuff. If you seal up a house really good, and then you put in one of these modulating furnaces, the only thing that it's going to adjust as far as how much heat it has to put out is going to be that outdoor temperature. So sometimes it'll have it where these furnaces will include an outdoor temperature sensor, so that as it sees basically the outdoor temperature drop, like let's say we have one night where it goes from, oh, it's 50 today, and the next morning, oh my gosh, is it down to 30 degrees? One of those nights where it just drops 20 and it doesn't get back up for like a week. or sometimes in Virginia, like 3 hours later. But still, that's and that's where it really comes an advantage here in Virginia and states like ours, where we have unpredictable, mild winters. In comparison to places out in the Midwest where you're having to work with boilers, you're having to work with really, really high temperatures of heat all the time because it's cold. It's really cold. I don't know if anyone's ever been to the Midwest in the wintertime, but yeah, you don't need to go. It's flights are cheap for a reason. Um, you can go to Chicago in January all you like. No one's going to complain. You might get a spike on as far as a flight price if it's a Blackhawks game or something, but that might be it. Even then, probably not. So, excuse me, voice is getting dry. So we've got it where the gas furnace that's modulating, it will, adapt to as much information as we can give it. Modern systems, a lot of times nowadays, is really, really cool how much information you can give a system. So I was saying before, you could give it an outdoor temperature sensor. You can also give it multiple temperature sensors in a house. So not just the one thermostat, let's say, tucked away in the kitchen or near the living room where there's no really doors nearby, except for maybe to the back deck or something like that, or to the backyard. And, but nobody's really going out there because it's wintertime, so we're staying inside. It's cold out there. So, that's where the thermostat's located, but that's not reading the temperature up in some of the bedrooms on the second floor, some of the rooms down in the basement, some of the rooms, right at the front entry. We got to move some, it's one of the biggest things that keeps a door open that people always will cool their house down is if they get a Christmas tree a little bit too late in the wintertime and they have to keep that door open for a minute and they're trying to make sure, okay, because we keep this open longer than 2 minutes, we're going to lose half the heat in our house, and we don't want to have to make that up with burning a bunch of fuel. So the nice thing is with a modulating gas furnace, if you do that, if you have it where it all of a sudden, okay, we just had a massive drop in temperature, it might have been running at a pretty low speed, but if you have a temperature sensor located there, if you have a temperature sensor located in the bedrooms, located in the basement, it might kick on a more regular basis and start heating up those other areas, especially if it's got zone controls with those sensors. And that's when these things go to the next level, basically. As far as energy efficiency is concerned, a zone-controlled modulating gas furnace is the ideal way to produce heat for one. You've got it where the heat exchanger, it stays hot. It's going to get hot, and the reheating of it is what causes damage. The reheating of it is what causes energy consumption. But if you stay and keep it hot all the time, because as one room gets warmer, the other one cools down, and the other one gets warmer, and the other one cools down, and it just goes back and forth between different rooms in the house all day long. It just constantly runs at a low speed, at a low heat production. That's going to make it so that your furnace lasts longer and that your gas consumption is going to be less. Basically, instead of having to, if you had a burner, if we're talking about a gas burner for like a stovetop, the old style furnaces, it was, okay, we want the water hot, turn it to high. That's the only option. We're going to get the water hot, it's going to be boiling. Water's done being hot, okay, turn it to 0. That's it. Now, this new modulating was able to basically, it cranks it up, gets it to boiling, and then puts it back down. Oh, we need to boil again? Let me crank it back up a little more. All right, we're good. And then back and forth. And it's just going to swing back and forth between low and high speed. And doing that makes it so that you have more comfort control in the building. You have it where you've got less cold and hot spots in a building. And all of these problems that come with a gas furnace. But like it's saying right here, optimize the performance level. It's using really interesting technology, lots of high-end devices, like I said, microprocessors. And I've seen some of them. I've seen the thermostats where you come by, if you're an HVAC tech, they give you some companies. My company I worked for, we had a Carrier, was our brand. Carrier had flash drives with files on them for updates for the system. And you would go by and you would go to the system and you would stick a flash drive in if it was given an error code. And, you know, it happened like one time when I was working with them. And you would plug it in and you would punch in the information and you would update the entire system so that it would fix itself, or it would be, have more information or be able to control its modulation better, because they're not perfect. They're not exact science. They're going to be a lot of, what the company thinks, oh, this will work in the lab. Let's see it in the real world, and then when it gets out in the real world, oh, there's all these problems. Well, instead of having to design a whole new board or something like that with these microprocessors, they make it easier because they just write new code, they write new program, they write new information, and the system picks up that information and is able to, okay, well, and this has happened before. I've seen it where there's been brands where there's notorious bad control boards for them for specific models or something like that, and they stop making them like after 1 year. Now this makes it so they don't have to do that. They can have it where, okay, well, we messed up on the control board for the control side of things. We have it good on the resistors and the relays and everything's working fine there. But as far as communication between, let's say, the outdoor and the indoor unit, how it decides when to turn on first or second stage heating, or, how it will crank up the heat and slow down the heat, throughout its modulating process. This is all stuff that they can adjust and they can update and they can change. And that's what makes it really, really cool to work on these new modern systems. I like them a lot because they've got those options. At the same time, it kind of sucks because if one of those boards goes bad, or if one of those components you think is bad or not working properly, you want to make sure, because those thermostats are like $700 and the control boards are like $1,500. So if it's messing up, it's one of those ones where you really have to sit back and be like, okay, well, I think it's this thing, you can't be, I think, you have to be, I know it's the controller. I know it's this thermostat. I had it before where I had a customer and we had a problem with the thermostat was supposed to hook up to Wi-Fi. That was the whole thing with it, which was really cool because now we control, and he could sit there in his chair. He wouldn't have to get up. He was an older guy, probably in his early 70s, and he was like, "Oh yeah, we've got it where I'll be able to just control it from my couch and chair." But the problem he kept having was it wouldn't connect to the Wi-Fi. And so our first suggestion, we're HVAC techs. I'm not an IT guy. I don't know how to check for your Wi-Fi signal strength, in a house or something like that. Probably figure that out now I'm thinking about it. But our whole idea was, well, get a Wi-Fi router booster or something like that. If you've got where you've got a weak signal over here, you can get a boosted signal, and maybe that'll allow it to pick it up. And then we had it where we get to the guy's house again, and he had bought the booster, and the thermostat was still not working. So now we had to say, okay, is it the thermostat? Is it the Wi-Fi? What's going on here? And literally all we did was we tested it with our phones, his phone, and the thermostat, and saw, all right, are they all getting the same like level of bars of signal for the Wi-Fi? And the thermostat was getting like 0, and we were all getting full bar signal, all 3 of our phones. And we're like, okay, this is definitely a bad thermostat. It was one of those weird things. We just didn't know how to make sure. Is it just this one component, or is it something else going on with the system? So modulating gas furnaces, they are pretty much what's getting into everything nowadays. So you're seeing it where it's able to control its speed. It's able to control its speed. It's able to control its heat production. That's the whole idea behind it. If we can control the amount of heat that it produces and make it so that it kicks on and produces high amounts of heat when we need it, that'll work better for us. The variable speed motors are one of the biggest things, but the variable speed gas valve is the biggest thing. That's one of the hardest things to troubleshoot is that gas valve. The main thing is to look at the full pressure when it's producing 100% heat. Now, you can either, like I said before, you can crank a thermostat up way, way up, or for these ones, on the control board, there's still going to be thermostat connections for R, which is your 24-volt power, and W, which is your call for heating. If you take a pair of jumpers and you jump R to W, you're going to have the heat kick on at full speed, max heat. That's one of the easiest ways to see whether or not, yes, is the board sending its signal? Are we actually going into max heat? Is this doing what it's supposed to? And if it's not, you'll know right away. So, so again, optimize furnace performance, utilizes variable speed blowers, variable speed, reducer transmitters, everything. This right here, the variable output programmable thermostat, this is the nice stuff. This is when you're dealing with high-end customers. You go to someone who's got a variable output programmable thermostat, they put some money in their HVAC unit. Either they value their home and their HVAC unit very much, which more power to them, or they just wanted the nicest thing possible. They just said, what's the best model you got? I want that one. These systems are really, really interesting. Like I said before, it's tough sometimes because you hope that it's not this weird, fancy thermostat that we're operating with or anything like that. But it ends up being difficult to troubleshoot them because it's a thermostat. It's all it's supposed to do is close a switch, send power. That's all it needs to do. But with these ones, because it's variable output, it's going to have it where it might not communicate by voltage. It might communicate by voltage and a binary signal, or just a binary signal. So we're talking about computer code. It'll just send a signal like your computer sends to another computer and says, oh yeah, by the way, you should just turn this part on, get the heat going. Those wires, the communication wires for the thermostat to a control board are extremely important. You have to make sure that they are not getting damaged. You have to make sure that they are not going to be bent or basically stressed in any direction. If they are, if they're bent, if they're broken, if there's any part of that thing that's damaged, it is not going to carry a clean signal. It's not going to carry that code, and we're not going to have it where the system can actually kick on and and work properly. That's the biggest threat we've got to it, is just the fact that the variable output programmable thermostat kind of sort of likes to work when it wants to. I've had it before where I've had a thermostat. I've gone out to a call, tried to figure something out with it, thought, oh, okay, well, thermostat's having an issue. Let me see if I can, figure out if it's communicating between the thermostat, the indoor unit, the outdoor unit. I take off the thermostat, to reset it. I put it back on, reconnect it, starts booting up. Okay, communication to the indoor unit, cool. Communication to the outdoor unit, nope, doesn't work. Shoot, I gotta run new thermostat wire. I was doing this for a friend of mine, and my friend was like, yeah, no, I'll check it out when I get out there, I'll see what's going on with it. I was like, okay, because it was his house, he had moved, and he was just trying to sell it, but he wanted me to see what was going on with the thermostat, because his electric heat had been stuck on in the wintertime, so it was heat pump. So I get out there, I can't, I'm seeing, okay, no communication between indoor and outdoor unit. And I'm like, all right, we're going to have to run new thermostat wire. Well, I don't have the time for that at the time. And I told him, what's going on. He knew HVAC at least, so he's good. And he calls me about a week later. He's like, yeah, I'm back out here. It's communicating to the outdoor unit. Heat's coming on like it should. I'm like, what in the world? Are you kidding me? Like, I couldn't get the thing to communicate, but then all of a sudden, just because time went by or whatever happened, my only worry is that it's going to happen again, And then that's the tough thing with these variable output, with these digital controls, with these high-end sophisticated devices, is we've got it where it can have more and more, of an effect on our ability to troubleshoot a system and how quickly we can troubleshoot it. And that just, it ends up costing time, it ends up costing money. It's difficult for us as technicians, especially when it's a problem that's there one day and then gone the next, and then there again the next day. Because I can't tell you how many customers I would go out to their house. It's working fine now. Can't tell you. I don't know what's going on. Don't know what happened to it, but it's working fine now. That was a really common thing that would happen sometimes. People would say, well, what? Are you sure? I'm like, yeah, no, it's doing exactly what it's supposed to. Let me know if something else happens, but, and take note, look out for these kinds of things. That was part of that education of my customers always, was trying to teach them and tell them, hey, if you do experience a lack of cooling or a lack of heating, look out for these key trademark, kind of things. For a lack of heating, I would always say, hey, check and make sure that your breaker's not tripped, make sure that the furnace emergency shutoff switch is in the on position. Basic stuff like that is what I would always be looking at and telling them to do and take care of, because that's the kind of stuff you can make sure, okay, by yourself, it's fine. But if it's something outside of that, then yes, call me back, get me out there, and I'll try to see what I can find. But keep an eye on the blower motor. How is that activating? How is that working? How is it? Is it always on? Does it seem to cycle a lot of times before or after you've been heating? That kind of stuff will point you in the direction of, okay, this is our solution. Here's the problem we've got going on with the system, but now we've got a solution already because we found out, what was going on with the system, because the customer knew to look out for certain things, And it just depends what kind of damage you're expecting, what kind of, how should I put this? Not so much on what kind of damage you're expecting or anything like that, but it's going to make it so that the customer will at least know, what you got going on, what they've got going on with that system. And depending on what kind of system, that's when you can recommend to look out for different things. If it's a gas furnace, look out for your burners. Make sure that you're having flame production. You can see that on the majority of gas furnaces nowadays. You can literally see the flames. So, check and make sure that that's working properly. Make sure that the flames don't just go out after being on for a second. Basic stuff like that. So, whether or not they get it, whether or not they understand it, that's one of the tougher things. But getting them to at least understand that this is an issue or this is a problem that can occur, that's a big step in and of itself. There we go. If I can get my words to work. So use fuzzy logic to calculate load factors. That's the nice thing about fuzzy logic. It's a computer programmed, algorithm. It's going to be an actual computer programmed, calculation of, okay, if we've got, it's like, you had it back in elementary school or middle school, where you had those word questions about, if a train leaves Chicago at 50 miles an hour headed towards St. Louis, how fast will it reach there? But if it wants to reach that place in 30 minutes, how fast will it have to go? For the system, what it does is it says, okay, well, how hot do we want it to be in the home? How cold is it outside? How long do we have to go? You want this heat to be there in 2 minutes? Cool. Let's get this going. Let's get it started. That's the whole idea behind that. Is basically it's going to be able to adjust and control the amount of heating, just because, okay, well, if we've got already got a high demand for heating because it's 0 degrees outside, that would require a lot of heat. I'm going to crank up that heat. I'm going to keep that heat going all day long. But if I've got it where it's 65 degrees outside, well, I'll go at a very, very slow speed. I've got plenty of time to get the same job accomplished as far as getting it to up to temperature, but it's not going to require nearly as much heat production. So that's the nice thing about these is that control of heat production more than anything else makes it so that with the logic of the computer and everything like that, it's able to figure out what works best and factor ahead of time almost. Some of them nowadays, honestly, they can factor ahead of time. They will literally be linked up to the local weather, and it will predict. It will say, okay, well, I see that the weather report is calling for rainy weather or colder weather or windy weather, and I will adjust my heat production according to that. It will adjust. Some of them you can get it where it will adjust to what style of house do you have? Is it an apartment? Is it a townhome? Is it a ranch? Is it just a 2-story house with an unfinished basement? Who knows? But it can actually adjust according to that. It just depends on how much moolah have you got to spend. So that's the really cool thing with a lot of these different systems. Load factor, again, used to determine when and for how long the furnace should be activated. It's trying to keep it where it's either on a low speed at all times or trying to keep it on a steady amount of heat production. But that's what we're seeing pretty regularly with this. So again, that's pretty much it for the slides and everything like that today. We will get back together at 2:30. I am going to be just basically hosting a live watch of a couple of YouTube videos. I'll send out a link with this video and those YouTube videos and everything at the end of the day or at the end of the next class, which would be 3:10, and my internet takes a little bit of time. It's probably about 4 o'clock. I'll have those emails out for y'all with all the information. But we'll be back at 2:30 to watch some more videos and go over some more stuff for these.